ask you to give me some insight about this data set here, you could probably tell me, okay, my ad has been served on New York Times.com. The guy who saw my ad was and he was using a Verizon. So I would say good job. Now let's say I give you millions of listeners today and ask you the same question. And then you will know so being able to do analytics at scale is essentially being able to understand your data and know you have to be able to figure out your data. Now when I talk about real-time analytics, essentially like how fast that doesn't really mean anything. But at GumGum we say that we are doing real-time analytics when we can achieve an average So once again, you need to sort of put the definition behind that. At GumGum, we say that we are doing real-time analytics in terms of data freshness when we can achieve an average latency ingestion of events at about 1 minute, 30 seconds. Because once again, we know people and we know that they're happy with that and they feel like they really about. Let me introduce my company. So GumGum, we have invented image advertising in 2008, which is basically the concept of overlaying ads on top of pages. So we have a bunch of image recognition technologies, and we are leveraging these technologies to serve relevant ads on top of images. So we have very high viewability because usually people, when they browse websites, they focus on images first, so they see our ads also first. In terms of numbers, processing 2.6 billion images per month. We are doing approximately 10 billion ad impressions a month, producing more than 10 billion events a day, working with top publishers like Coca-Cola, Cadillac, Disney, and so on. We are growing a lot. We are 167 right now, but we are not growing a lot only in terms of number of employees, but also in terms of the data volume we are producing on a daily basis. So obviously, people who are working at GumGum, they need to get insight about this data, right? They need to understand it, and what we need to give them is basically interactive data exploration, meaning that they need to be able to access different viewpoints on this data. They need to, be able to refine their queries along the way until they get the answer they are looking for. And they need to do that fast, and not wait minutes every time they refine their queries. And they need to be able to access fresh data because it's a big requirement for us when we are running ad campaigns. We want to know how many ads we're selling at the very moment in order to know if something is wrong and we have to adjust some stuff in this ad campaigns. So in order to fulfill these requirements, we have adopted really happy about it. We have adopted 2 years ago, and it's powering most of our dashboard right now at GumGum, our analytic dashboard. So some key features about Druid. It's good at what we call arbitrary slice and dice on data. So it's basically good at giving you different viewpoints on your data, breaking down your data into smaller parts, zooming them out, and filtering it efficiently. It's meant for fast aggregations on time series data. So first of all, Druid only understand time series. All of the events you ingest in Druid needs to be timestamped, otherwise you don't understand. And also it only understand dimensions and metrics. So dimensions for us would be publishers or advertisers, and metrics would be number of clicks, number of views, ad impressions, revenue, stuff like that. So what it means is that it's really good at aggregating your metrics over your set of dimensions. So it's highly available. There is no single point of failure. It's production ready. You should always be able to query your data, even in case of power failures or whatever. It's real time, meaning that it's fast to query and gives you access to fresh data, and it's distributed. So it scales linearly. You can add more nodes easily if you see that your data will be queried. So now let's take a look at how Druid works at a very high level, and first let's see what the Druid cluster looks like. So basically, a Druid cluster is a set of different type of nodes, and each type of node is designed to do a specific set of things very well. And all of these nodes, they work together from this system that is able to, solve your analytics problems. So everything starts with some queries. You queries each of broker nodes first, which are basically query workers. Other kind of nodes, which are the workers in the Druid cluster. The first node or type of node or type of worker is called the real-time node. This node is basically responsible of aggregating or ingesting your streams of data in real time, and it makes this data immediately queryable to clients. So behind the scene, basically, when your events goes, they go here, it gets aggregated in real time, and then at some point, these real-time nodes, they flush them out of memory and persist them in the immutable representation of your data. That is basically handed off to some other kind of node that are more designed for dealing with immutable data, which are the historical nodes. And those nodes are basically the main workers in the clusters because they hold most of your data, right? The historical data. So what they do is basically they load data from deep storage and they respond to queries. That's all. So deep storage, it's the layer that ensures you're not gonna lose any data in Druid. So you can use Cassandra, you can use S3, you can use HDFS. And so if I have to sum up, so your queries each your brokers forward your queries to the right nodes. And then your query gets computed in parallel over your set of brokers. All your nodes give back their result to the broker, and your broker merges those results to the final one that is given back to your client. So there is also a concept of data balance and replication in Druid. So the data unit in Druid is what I mentioned earlier. It's called the Druid segment, which is an immutable representation of your data. And each Druid segment is associated to a time interval and basically a segment metadata. So all this metadata is stored in MySQL, and there is another type of node which is called the coordinator. And this coordinator, basically every time it runs, it reads MySQL, understand what data should exist in your cluster, and then ask your historical nodes to load new segments from deep storage, drop outdated segments, or even move segments from one node to another for data balance, or even replicate your segments if you have configured. So that's the main role of the coordinator. So what about data ingestion? How do you put data into your system? So you have two ways to do that. First, you can obviously use your real-time nodes and their real-time ingestion capabilities, right? So you can directly ingest your data from a pub message system like Kafka or RabbitMQ. If you need an ETL layer in between, you can use Storm. That's what we do at GumGum. So we pull logs from Kafka, we parse those logs, we extract dimensions and metrics, and then we feed our real-time nodes with this processed data. You have also the batch way to do that. So you can use the Hadoop Druid indexer that comes with the Druid project, which is basically just a MapReduce job. And this job basically takes an input, for example, CSV files where you put like your dimensions and metrics. Once again, takes those files, index them, create segments out of them, and then store these files or these Druid segments to your deep storage layer. Then it updates MySQL here, and in order for Druid to understand that it has to load these new batch segments, and if necessary, Druid will automatically replace your real-time segments by your batch segments that you are producing here. So that's a very high picture, big picture of how Druid works. Now we can try to explain why it's also fast to query. So Druid is basically a columnar data store. So for those who are familiar with what is a columnar data store, you will understand that this is one of the main reasons why it's fast to query. So if you take the example of this data set here, so you have dimensions, right? Product, articles, and you have a bunch of metrics. Once again, at impressions, clicks, revenue. And if you, let's say you want to query Druid and you want to perform a query or aggregate your metrics over your vertical dimension here, Druid will only scan this column. They will directly skip, obviously, the product dimension here. They are also using column compression with dictionary encoding. So all your dimension values that you are seeing here on their string representation, they are not stored like that in Druid. Basically, Druid map those string values to some internal IDs. So basically here, this example gaming gets mapped to 0, fashion gets transformed to 1, and then Druid only stores an array of these internal IDs that represent your data set. And this representation that you can see here is pretty easily compressed, so it's easy to understand that the more you can compress your data set, the faster you'll be able to scan it and query. On top of that, they use what we call inverted indexes, which really help Druid to narrow down the data it has to scan every time you apply a filter on your query. So let's take an example here with these data sets. So for each value of your dimension, Druid is going to create this inverted index, which is an array of bytes basically, which represents where a certain value was seen. So 1 if it was seen, 0 if it was seen. So for the example of gaming, it was seen in the first 2 rows, so it will happen 1 and 1 in this array of bytes, and 0, 0. Fashion was seen in the last 2 rows, so it will be 0, 0, 1 and 1. So now, let's say you want to query Druid and you perform a query that focuses on the gaming value of your dimension. Druid will only quickly figure out that it has to scan only the first rows in that case. Now let's say you want to query Druid and you are looking for gaming or fashion, then you can take those 2 indexes here, or them together, and you can quickly figure out as well that you have to scan your entire data set here. So they use also compression for to compress these indexes. One of the algorithms they are using is called the consist compression. I'm not going to talk more about it, but what is cool about it is you can basically compress your indexes, and you can still perform Boolean operation on their compressed form, so it's even faster, to process. So those are the main reasons why Druid is fast query. But it doesn't explain why it gives you access to fresh data. How does it do, this fast aggregation on your real-time data? So if you want to understand that, you sort of need to zoom in what's really happening in the real-time nodes, because those are the nodes where all the magic happens, right? It's where you're ingesting where you're ingesting real-time data. So in this process, you have two main components. One is the write optimized and one is the read optimized. So first, your events comes in this write optimized component, and that's where your events gets aggregated essentially. So behind the scene here, Druid use like a gigantic hash map where all the keys are basically a hash of your dimension values. And every time an event comes in, Druid does a lookup on this hash map and then try to find an event where this new event can roll up into. If it doesn't find anything, it just happen this new event to this hash map. So this process is really write optimized and really fast to aggregate your data, because hash map is one of the fastest data structure you can write to. But because Druid has to also be able to query this data very fast as well, your aggregated data doesn't stay that long in this component. It gets flushed out of it periodically and then persisted into the Druid segments, which is really a read optimized data structure, right? Because it's in the columnar format, because it's immutable, and it has all these indexes that really help Druid speed up your queries. So they get flushed periodically, and then in this process, a bunch of segments get created, and then at some point, Druid will merge all these segments, create a final segment which will be ended up to the historical nodes, which once again are more designed or specialized to deal with mutable data. So that's why Druid can give you access to fresh data and allows you to query this real-time data pretty fast as well. I'm going to end this presentation by just showing you a diagram of our current architecture at GumGum. So we are using a Lambda architecture at GumGum with a real-time and a batch pipeline. So for the real-time pipeline, we basically use the combo Kafka and Storm. So our ad servers basically sends our log events to Kafka. Then we pull those events with Storm, we parse our logs, we extract dimensions and metrics, and then we send this process data to Druid and our real-time nodes for real-time ingestion. For the batch pipeline, we use FluentD, so our ad servers basically sends the logs to FluentD. FluentD aggregates those logs, creates files out of it, and store them to S3. And then every hour we trigger Spark jobs to process these files, and we store the output back to S3. And then we use the Hadoop Druid indexer to create Druid segments out of this process data that is once again stored in S3 because it's our deep storage layer in Druid. And then this job update MySQL Druid, and then the real-time segments that we have been producing here gets automatically replaced by our batch segments. So if you're wondering why we are still maintaining those two pipelines, right, it's kind of redundant. It's because we still feel like the state of the real-time processing technologies are not still 100% reliable. Some of your events might be over-delivered, and you miss some of your events. So if you want to, fix those failures, you still need to maintain a batch pipeline and replace basically your real-time data by your batch data. So we don't expose directly our data, the data we have in Druid directly to our customers. We have a reporting server in between, which is just the REST API. And what it does, among other things, is joining the data we have in MySQL with the data we have in Druid. It does that in memory. So in MySQL, we have like dimensions table, for example, the list of our publishers, the list of our advertisers, with a bunch of informations. And in Druid, we only ingest IDs, publisher IDs, and advertiser IDs. So if you want to link some information on these IDs, you sort of need to do your join by yourself. It's not true anymore because Druid allows you in the last versions to kind of plug your MySQL tables and do this join inside Druid itself, but it wasn't available when we started to use Druid, so we did that on this layer, on this reporting server API here, and then we just expose these joins to our clients. I think that's it for me. So obviously GumGum is hiring, so if you guys want to check out our websites, we have some pretty cool open position open. We are also doing internships if you're interested. So if you want to work with cool technologies, just check it out. I think it's pretty cool. Here are some useful links. This guy it's a company called Imply, and it's backing up basically the Druid project, and they're building an ecosystem around Druid. It's a pretty cool project, so you should check it out. And then this is the main Druid websites where you can find useful information as well. If you want to reach out, there is a link here. Thank you very much for your time.
Anybody has any questions?
I was wondering how big your Druid cluster is.
First, for scaling, historical nodes that you typically scale at with your pressure, does that fluctuate with your historical nodes you have? For scaling, when you also have more volume, you have more currency, more users, typically with historical nodes that you scale out. What part of it is that you'll scale? You need to serve up more queries at lower latency.
But so MySQL couldn't keep up, obviously, because the traffic was increasing and it wasn't meant for that. So we were looking for this new solution that would be able to batch and real-time ingestion. And I think at the moment, so it was more than 2 years ago, there was only Druid around. We decided to go Druid. Plus Druid was built by an ad tech company like us, and they had kind of the same use cases, so we decided to go for that. But I cannot tell you if you can if you have more technologies that you could use for the same use cases. I think Druid is pretty training right now. MySQL, you mean? So you mean only for coordination purposes? Yeah. Okay, so the coordinator basically they kind of have memory. They kind of have a big picture of the MySQL data that you have. So I think if Druid goes down, they basically use whatever state they have in memory. And so basically, if your MySQL Druid is down, even though you are producing more segments, for example, with your pipelines, you're not going to see them in your Druid cluster until MySQL comes back, right? But the data you are still able to query will be still accessible for your players. So if I would say if MySQL doesn't go down for more than 1 hour, then you're fine. Still gonna some trouble, right? It's not. Yeah, we don't have. There is a SQL layer, but it's not full NC SQL. It's called PlyQL if you want to check it out. I mean, I think we could basically replace completely Redshift by Druid, but the contrary is not accurate. Because, I mean, Redshift you cannot ingest your streams of data, right? It doesn't work. It's like you process your data and then you ingest really big batch of data essentially, which wouldn't work with the streams. Oh, okay. Okay, so I guess the contrary is now true. Oh, what's the name again? Okay, yeah. Sorry, we can. Thanks again.
You have the next.